Alright guys, welcome to our first math lesson of the year. You can go ahead and have these notes printed out from our website and you can just add to them, or you can do them completely by hand. I like to go ahead and start off by just telling you what we're going to learn. Just so you guys know, a lot of this year is going to be just reviewing some old stuff, because like we said, pre-calculus is a way to get you ready for calculus. And when it comes to calculus, actually, one of the hardest things that students experience is just trying to remember all the old stuff. So pre-calculus is really just an opportunity to refine all of your old skills before you go into calculus. But we actually will be learning some new stuff, but absolutely everything that we're learning in this first unit you should have learned before. So let's go ahead and jump in. So today we're going to talk about what a linear function is. So that'll be the first thing we do. And then we're going to talk about how to find slope and y-intercept of a given table, graph, or equation. And then we're going to determine if the linear function is increasing, decreasing, or constant. So those are our three objectives for the day. Before we begin the actual lesson, what I'd like you guys to do here is go ahead and pause the video for a minute and work on numbers 1 and 2. Now, the purpose of this warm-up is to kind of jumpstart your minds with the stuff that you already know, to see if it'll kind of make all of what we're talking about today make a little bit more sense. So like I said, pause the video here, complete these number exercises 1 and 2, and when you're done, unpause the video and I'll go over it with you. Okay, so make sure that when I say pause the video and exercise, I mean, you don't have to. You can ignore me and just wait for me to do it anyway. I would not encourage that. Half of what you guys are going to be learning is based on what I tell you to do, what I tell you guys. But the other half is you guys actually picking up your pencil and doing it. So if you're always just watching, you're going to severely disable your ability to get stuff. So make sure that you guys do the exercises whenever I tell you to pause the video and give them a try, okay? All right, let's go ahead and begin. It says, a car rental agency charges $300 up front to rent a vehicle, and then you must also pay an additional $25 a day that you keep the car. So complete the table and graph here. So we're going to complete this table, and then we're going to graph it over here. So now notice we have two variables we're looking at. Our variables, which you could call one of them X and you can call the other one Y, are days and cost. So we're going to say that days represents our X values and cost represents our Y values. Those are our two variables. Well, on the day that you rent the car, we'll call that day 0. They asked for $300 up front. So right there, it's cost you $300 before you've even had it for a whole day. Now, after you've had the vehicle for 2 days, well, each day that you owned it, they charged you $25. So 2 days, that's an additional $50 that they charged you. So now you owe them the $300 plus an additional $50 because 2 days went by. Okay, let's go ahead and take a look at the next one here. How about after the 7th day? Well, after you've had the car for 7 days, that's $25 a day. So we're going to go ahead and multiply 25 by 7 to figure out how much we owe them for 7 days. 14 plus 3 is 17. So that's $175 plus the $300 that they charge up front. So $25 a day plus $300 up front is going to be $475. So now we owe $475. Okay. Now before I jump into sketching this, I think a really natural thing to do is to just kind of show you there's an equation here that you guys might not even realize that you're doing, but you are. Okay. So you know that what you do is you're taking $25, right? And you're multiplying that, so I'll put a dot. You're multiplying that times the number of days, so we'll call that X, right? So you're doing 25 times X. And then after that, you add the amount that they're charging you up front, $300. And that will tell you the cost, right? So if you take the $25 per day and then add $300 to it, that will tell you the cost, which is Y. So that equals Y. And this should look kind of familiar to you guys. We have Y equals 25X plus 300. That should look like something that you've seen in the past, and that's what our whole lesson's about today, is equations that look like this. Okay, those are what we call slope-intercept form linear equations, and that's what we're going to really be focusing on today. Now, So now that we've looked at this table and we know what, you know, a slope-intercept equation is, let's look at a graph really quick. As you guys know, when you graph something, the y variable goes here, the x variable goes here. So let's go ahead and plot this thing up. So I'm going to put 300 right here. I'll put 400 right here. And I'll put 500 right here. Okay, and as for days, we're going up to 7. So 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, and 7 days. And we're going to go ahead and graph this. So at day 0, we have we owe $300. I'm going to put a dot right here for $300 at day 0. And then by the time we get to day 2, so day 1, day 2, we now owe $350, which would probably be like right about here. And then by day 7, we owe $475. So I'm going to go over here to 7, jumping up here to 400. 450 would probably be like right in between the 500 and 400 here. So I'm going to go up a little bit more for 475 and put a final dot there. And we're going to go ahead and connect these dots. And depending on how well you drew your graph, what you really should have ended up with here was a straight line. Okay, and linear functions like this, in this form y equals mx plus b, they always come out to be straight lines. And as you guys remember, they have various characteristics like the y-intercept, which is the starting amount, and they also have a slope, which is the number that is right here in front of the x. But we're going to get to all that. But this was just a nice little warm-up to kind of recharge your minds on an old concept known as the linear functions. So let's go ahead and jump into the rest of our lesson here. Okay, so first of all, what is a linear function? A linear function is a function that has the form y equals mx plus b. I'm sure you guys have seen that before, right? This is what we call the slope-intercept equation of a line. Now, they can come in other forms and still be linear. For instance, we have the standard form, which looks like this, but we don't generally prefer to work in this form very often, and this is the one that we prefer to use most, is this slope-intercept form with the m representing the slope and the b representing the y-intercept. Just really helps with understanding how to graph, and usually functions are written in such a way that the y is all by itself, whereas down here in the standard form, the y is not by itself. So we're going to be working mostly with y equals mx plus b form, and if something's not in that form, we are going to change it. Now, whenever you graph one of these functions, they look like a straight line. Okay, their slope doesn't change. Now, that might sound kind of like an odd statement to make, but their slope is always the same. So, for instance, suppose I had a straight line graph. So here's an example of one. The red line is some equation, which is y equals mx plus b, okay? And the slope of this line would be something like m, we'll just say. So what do I mean by the slope of this line it doesn't change, or it's unchanging? Well, what that means, it doesn't matter what 2 points you pick. Like, let's say I pick from here to here. If you were to go over and up, you would have a rise and a run, right? And slope is rise over run, which we'll get to in a minute. But no matter what 2 points you pick, if you did rise over run, you'll always get m. It won't be different. Now, for other types of functions, that's not true. Whatever 2 points you pick, you could potentially get different answers each time. But for a straight line, no matter what 2 points you pick, you'll always end up with the same answer for your slope. So let's go ahead and take a look then at slopes a little bit more carefully to kind of dig into that. So part B, what is rate of change? Okay, well, rate of change is really just a fancy word for slope. So I'm going to go ahead and write that there. Rate of change just tells you how quickly each variable in your equation is changing. All right, so what do I mean by it's the slope is the rate at which the variables are changing? So You don't need to write this, but as you guys know, you're probably very familiar with the idea of slope, right? You have 2 points, you have a run, and you have a rise, right? Well, the distance from here to here, that tells you how much your x has changed, right? You went from this x value to this x value, so that's the change in x. How much did x change? We went from here to here. And the change in x is just another word for the run, right? The run represents how much your x value changed. You started this far left and you ended up this far right. And then the distance from here to here, that tells us how far up we went. That's our rise, correct? So, but that going from here to here, that's a change in y. So what a slope is, as you guys know, slope is rise over run, right? Well, basically, it's the change in y being divided by the change in x. And what that tells you basically is how fast is y changing as x is changing. So in other words, if you had a slope that looks like this, 2/3, that means that your y increased by 2 every time your x increases by 3. Okay, and so that's why slope is also known as rate of change, because it's talking about how fast your 2 variables, x's and y's, are changing. So I'll read my notes here and see if that kind of puts a cap on it. So the rate of change of a function is the ratio, that's just a fancy word for fraction, the ratio of the change in y, here's the symbol we use for change in y, to the change in x. There's the symbol we use for change in x. So instead of saying rise over run, we could say change in y over change in x, right? But we have symbols for those. This is change in y and this is change in x. So rise over run can be written as delta y over delta x. I didn't tell you that yet, but that little triangle, you might want to make a note here. It's called a delta, and it means change. Okay. Now, how do we usually find out what the change in y is, and how do we usually find out what the change in x is? Well, basically we have 2 points on our line, right? x1, y1 is one of our points, and x2, y2 is another point on our graph. And I'm going from this point to this point. Well, if I want to find out what's my change in y, for instance, I'm going to take my last y value and my first y value, and if I want to find how far apart they are from each other, in other words, how much did my y's change, I would subtract them. Same thing with the x's, or the change in x. If I want to find out what my change in x is, I'm going to take my second x value, how far over did I end up right here, right? I ended up this far to the right. And then I'm going to take my first x value, which is my point to the left, and I'm going to subtract them to find out how far apart those 2 numbers are. And that will tell you your run. So you have your y2 minus y1 over x2 minus x1. That's your change in y over change in x, which is also known as rise over run. And we usually use a symbol to represent slope when you're talking about linear functions, and it's m. And there you go. And we've already talked about how rate of change is just a fancy word for slope. So let's go ahead and review it one more time. Rate of change is a fancy word for slope. It's represented with the variable m. And you can calculate it by doing y2 minus y1 over x2 minus x1. The y2 minus y1 represents delta y, which is the change in y. The x2 minus x1 represents delta x, which is the change in x. Change in y and change in x are just fancier expressions for rise and run. So you guys remember from Algebra 1, all they really talk about is m and rise and run, right? Actually, they talk about this too, but they don't get into rate of change and delta y and delta x, from what I remember anyway. Let's go ahead and move on to the next topic then. All right, so increasing versus decreasing rate of change. Remember, that's just another word for slope, okay? And I actually just realized I had an error there. I had increasing versus decreasing rate of change, but what it shouldn't say rate of change or slope, actually it should say function. Okay, so on your notes, fix that. If your notes say rate of change or slope there, put the word function here. what does it mean to say that a function is increasing or decreasing? Okay, well, let's start easy. Okay, you guys remember slope could be positive or negative. It could be 0 as well. Okay, and as you guys might remember from Algebra 1 and Algebra 2, positive slopes look like this. They go up to the right. Negative slopes look like this. They go down to the left as you move to the right. 0 slopes look like this. They're just flat lines. So as you go from left to right, the height doesn't change. So an increasing function is a function where the slope is positive. And what that means is as you move to the right, your function goes up. So they call it a increasing function. Okay? On a graph, when you go to the right, that's positive. When you go up, that's positive. And as you guys know, my rise and run here are both positive then. So when you put a positive number over a positive number, you get a positive outcome. And so the slope is positive. Now, a decreasing function. That means that as you go to the right, the function goes down. Okay? So even though I'm going to the right, that's a positive run. My y values are actually going downward. That's a negative. And so your rise over run will be a negative over a positive in that case. And a negative being divided by a positive results in a negative. And so you have a negative slope there. Okay. So increasing functions are functions where the y values are increasing as the x increases. Decreasing functions are functions where the y values are decreasing as x increases. Okay. A constant function is a function where the y values don't change at all as x increases. So we are going to the right, so x is increasing, but the y values don't change. The function doesn't go up and it doesn't go down, so the y values aren't changing. Okay, so that's what a constant function is. So we have increasing function, decreasing function, and constant function. Okay. Now, just something to add to our notes here. Let's go ahead and talk about the undefined slope. All right. So this up here is my nasty handwriting. It says undefined slope. And what an undefined slope is that when you're looking at a function, the x value is not changing at all. So like the graph looks like this. So anytime you have a graph that's vertical, completely vertical, that's an undefined slope. Now, why is it undefined? Well, your x isn't changing. On all these problems, notice that we always went from left to right. So I always increased my x value. Start from the left, go to the right. Increase the x value. Start from the left, go to the right. Increase the x value. But here, we're just going straight up. So we're not changing the x value at all. So your slope in this case, the change in y could be anything. We don't know. The y could go up or down. It doesn't really matter. But the x is not changing at all, so it is 0. And as you guys know, you can't have 0 on the bottom of a fraction, so that would be an undefined slope. Now, let's jump back here to a constant function. With a constant function, we do have a run. The x value is changing. We are going from left to right, but the problem is there's no change in the height. Now, it's okay to have 0 in the numerator of a fraction, but it's not okay to have a 0 in the denominator. When you have a 0 in the numerator, that just means the fraction equals 0, so that's why our slope is 0. But when you have a 0 in the denominator, that number actually doesn't exist. It's undefined, so therefore we'd say our slope doesn't exist. So if you guys haven't been writing this, I would encourage you guys to add everything here that I've added. You don't need to, you could add these little lines here where I put pluses and negatives, can't hurt. But definitely think you guys should include these signs here and these expressions here. Okay, so let's go ahead and move on to our next topic here. All right. Y-intercepts. Let's talk about those for a minute. So I think the easiest way to understand what a y-intercept is from the perspective of a graph. A y-intercept is the place where it touches the y-axis. Okay, so I'll start off with that definition. It's the place where a graph crosses the y-axis. Now, what's significant about that point is you're going to have a value for y there. I'm not sure what it will be. But no matter what, anytime you're on the y-axis, the x value will always be 0. So another way of thinking of what the y-intercept is is it's the value of y when x equals 0. And so basically what that does is that kind of gives you a way of knowing how to find the y-intercept of an equation at any time. All you have to do if you want to find the y-intercept of an equation is plug 0 in for x. Same thing applies if you guys ever want to find an x-intercept. We're not going to get in that right now. But if you want to find the x-intercept, you plug 0 in for y. But to find the y-intercept when you're working with an equation, you just plug 0 in for the x. Now, the initial value. I think a good way of talking about that would be to revisit our warm-up here for a second. So let's go back to our warm-up for a minute. So when we were talking about this car rental agency, right, you can see this is our y-intercept, it's the 300. But if you guys remember from our word problem, that's the amount of money they charged us up front before we even kept the car at all. So in other words, before the story even begins, we already owe $300. That's the starting amount of money. So another word for starting is the initial amount. So starting amount is the initial amount. So in word problems, a lot of times the initial amount or the starting amount is going to be the y-intercept. And so that's why we can call a y-intercept the initial value. That's what we're talking about whenever we're looking at word problems, particularly those word problems that have to do with time, like we were looking at cars over the number of days. So, all right, well, that's all the content that we were going to talk about today, but we are going to do some examples to bring all this to life, so don't check out of me yet. But our objectives were to describe linear functions, so you guys know what a linear function is, to know what slope and y-intercept are when you're looking at a table or a graph or an equation, and then to know whether a linear function is increasing, decreasing, or constant. So let's go ahead and take a look at some examples now to start bringing this to life. So I'm going to do some actual math problems now, and then you guys are going to get to practice it as well. So here we go. So example 1 here says, for each linear function below, determine the value of a couple of things. They want us to find the y-intercept, slope, and then they want us to say whether the function is increasing, decreasing, or constant. So we have 3 things we're going to do for each problem. Find the y-intercept, find the slope, and then determine whether the function is increasing, decreasing, or constant. Okay, so let's go ahead and start here. So for we'll call this part A, we'll call this part B, and we'll call this part C. All right, so for part A, y-intercept, that's where it touches the y-axis. So my y-intercept is right there. So we would say that our y-intercept is 0, -2. Okay. Part B, we're being asked to find the slope. Now there's a couple ways to find slope. You could do it in a variety of ways. I'm going to show you a couple ways. The one way I'm going to show you is probably the way you want to go with, but it's a little bit longer, but there is a faster way. So I'll show you a faster way in a minute. So what you're going to do is you're going to pick 2 points on your line. So let's use the y-intercept, but let's use another one. Now, any point you pick, make sure it lands on a point that you can actually find the coordinates of. Like the one up here, for instance, that I picked, I know that the x value is 1, and I know that the y value is 2. You would want to pick a point like right here, because we really don't know what the x and y is there. It's in between numbers, so it's kind of difficult to tell what that one is. So you want to pick a point where you can actually find the x and y values. But it doesn't matter which point you pick, just so you know. You can pick anything you want to. And I'll go ahead and use the y-intercept as well, which we already know is 0 and -2. Okay, so I'm going to show you guys 2 ways to find the slope when you're looking at a graph. The first way I'm going to show you is a little bit longer, but what I like about the first way is that it always works and it kind of avoids forgetting something that the other method doesn't always give you the benefit of. But the benefit of the other method is that it's just faster. So let me start off by showing you the long way, and then I'll show you the short way. Okay. So first of all, what I'm going to do is I'm going to label these 4 numbers. Okay. The first numbers are x's, and the second numbers in each pair are y's, right? So we'll call them both x and y. Now, typically what I recommend doing is the number that is to the left, or the point that's to the left, we're going to call that the 1. And the point that's to the right, we're going to call the 2. However, just so you guys know, it really doesn't matter which one you call the 1s and which one you call the 2s. To me, it makes a little more sense to me when I do it. we're going to call the numbers here x2, y2, and the numbers down here x1, y1. Now we're being asked to find the slope. Now, as you guys know, slope is y2 minus y1 over x2 minus x1. So what is my y2, first of all? My y2 is 2. Minus y1, what's the y1? It's negative 2. Over x2, what's my x2? 1. Minus x1, which is 0. So we have 2 minus a negative 2 on the top. What's 2 minus a negative 2? Well, double negatives make a positive, right? So you really have 2 plus 2 there, and that's 4. So 2 plus 2 is 4. And then 1 minus 0 on the bottom is 1. So we have 4 over 1, and you can leave it as a fraction if you want to, but 4 over 1 you can really just write as a whole number, 4. So in this case, my slope is 4. So this is kind of how I'm going to recommend most of you guys do it all the time, but you don't have to. I'm going to show you a faster way. But the method, once again, is to label your points and then do the formula. Okay? So let me show you another way of doing it, and then I'm going to let you guys practice one. Okay? Here's the other way of doing one. You really don't need to use numbers at all, so that's kind of what's nice about it. All you're going to do is pick 2 points. It doesn't, once again, it doesn't really matter what 2 points you pick, but I'm going to pick, once again, the 2 that are at definite points, right, that we can know. And you're just going to start on the left, and you're going to go over and up, and make kind of like a little triangle. Now this over distance going to the right is my run. So how far over did I go? Well, I went to the right, so that's a positive, and I went to the right 1. And then I had to go up 1, 2, 3, 4 spaces. So I went up, which is also a positive, up 4 spaces. So my rise is 4, my run is 1. Rise over run. Okay. Now here's what, even though it's easier, two disclaimers about this method. First of all, you've got to remember your signs. Right and up are positives, if you're going to do that. Left and down are negatives. Okay, so you got to get that right. That's something that if you're not careful, you're gonna goof up on getting the signs correct. You'll get, most often students will get the numbers right using this method, but a lot of times they get the signs screwed up here, and so they get it wrong. So just know that right or up are positive values, left and down are negative values, and that's how you're going to plug it in. So that's one disclaimer for this method. The other disclaimer is, of course, this only works for graphing, right? If you're dealing with graphs. Now, if you don't have a graph, finding slope is going to change a little bit. Anyway, now I always get students will ask this question, though. They'll say, well, Mr. Bailey, I noticed that you started with the point on the left, but can you start with the point on the right? And the answer is yes, you can. To do that, you would have to go left 1 space. Now that's left, so it's negative 1 space. And then you'd have to go down 4 spaces, and down is also negative. So now you've got negative 4 over negative 1. Double negatives cancel, and you still get the same answer. And still, students might ask another question. They might say, well, okay, well, what if I noticed, Mr. Bailey, that down here you went to the right first, and then up here you went to the left first, but can you go up first? And then to the right? And yes, you can. It doesn't change anything. You still have the same rise, and you still have the same run. So it doesn't really matter what you do first or which direction you go. It just matters that you give those the correct numbers and the correct signs to those numbers, and don't forget it's rise over run, and you'll get it. So that second method is faster, but you got to be careful with your signs when you're doing that method. So part A, y-intercept is -2. Part B, finding your slope. You can use the formula, or you can just use your rise and run from looking at the graph. Now we got to determine, is it increasing or decreasing? Well, since my slope is positive, that means it's increasing. But you can also tell that this function is increasing because just the way it's going. Anytime you have a graph that goes up as you're going to the right, that's a increasing function, right? So I'm going to go ahead and let you guys try one of these really quick before I go any further. I've been talking to you a whole lot. Why don't we have you guys just do number 2 here? This is your student practice down here, but I'm going to go ahead and skip that. I'm going to ask you guys to try number 2. Just give number 2 a shot. See if you can find the slope and the y-intercept. Pause the video here. Find the y-intercept, the slope, and then determine if it's increasing, decreasing, or constant. So go ahead and try number 2. Pause the video here. All right, so I'm going to go over the answer here. So the y-intercept is 1, so that's pretty simple. Where it touches the y-axis. Part B, I don't think I like this color. It kind of hurts my eyes. Let's do black. All right, I'm going to use the fast way first, but for those of you guys that didn't use the fast way, I will do a different method. By the way, I'll do something else a little bit different too here. I'm going to pick this point. Now, some of you guys might have picked this point, and that's fine, but they actually had a whole bunch of points you could have chosen from here. But I'll go with these 2. So in this case, I would have to go over 4 spaces to the right. So that's right 4, so plus 4, and down 2 spaces. Down is negative. So my rise is -2, my run is 4, and so if I reduce that, which you should do, you get -1/2. Now, if instead you had picked these 2 points, like here and here, well, guess what? You'd still get -1/2. You just wouldn't have to reduce. So the reason why it doesn't matter what 2 points you pick is because we said earlier for a linear function, the slope doesn't change. No matter where you're at, it's always the same. It's not true for other functions, but it is true for linear functions. All right, so we have our slope, which is -1/2. Now, I'm going to show you how to do it the long way, but if you already got the answer correct, or if you just don't care about using the long way right now, you can fast forward this part until I'm done. So I'm going to go with these same 2 points, though. So my points are 0, 1, and 4, -1. And for the points on the left, those are the ones that I like to call the 1s. And the points on the right, those are the ones I like to call the 2s. So we do y2 minus y1 over x2 minus x1. -2 over 4. Same thing. It just is a way to calculate the answer instead of looking at it geometrically. All right, so last question. Is it increasing, decreasing, or constant? Well, anytime a function goes downwards, that's decreasing. But another way you can tell is since my slope is negative. So the answer is decreasing for part C. All right, let's move on. Before I get into some table questions, I want you guys to try to do this problem now. Same thing, go ahead and find the slope, the y-intercept, and then tell me if it's increasing, decreasing, or constant. So if you haven't paused the video yet, go ahead and do so because I'm about ready to go over the answers. So the y-intercept, as you guys can see, where does it touch the y-axis? It touches the y-axis at 3. The slope. Now, it's a real easy way to get the slope here. It's a flat line. Those slopes are always 0. But if you want to go with the ways that I taught you, like if I went from here to here, for instance, well, my run is 2, so I went to the right 2, but it didn't go up at all, which means my rise is 0. And anytime you have a 0 on the top of a fraction, the outcome is just 0. Now keep in mind, on your homework, you might end up seeing a vertical line. Remember, those are different. That's undefined because then you have a 0 in the bottom instead of the top. Okay. Now the next question is it increasing, decreasing, or constant? Well, as we go from left to right, are the y values increasing or decreasing? No, neither one. The y values don't change. No matter how far to the right I go, the y value is always 3. So this is what we call a constant function. Flat lines are always constant. Okay. Now, I'll give you guys another opportunity to try one more problem, but you don't have to. So if you feel like you've gotten the graphing thing down, you don't have to do this next example. But if you feel like you want one more practice problem, go ahead and pause the video and try 2, and I'll put the answers up. So there's the answers for number 2. Y-intercept is -2, slope is -0.5. It's a decreasing function. Okay? All right. Now, just for the heck of it, before we move on to the next problem here, if you know what the y-intercept is and you know what the slope is, you can actually know what the equation of the line is. And we're going to get to that on another day. But your slope goes here. Your y-intercept goes here. So the equation of this line is -0.5x minus 2. Okay? But we'll get to that on another day. Or maybe a little bit in today. We'll see. I don't know. All right. So we've talked about how to find slope and y-intercepts when you're looking at a graph. But what about when you're looking at a table? Well, you can make life a little bit harder on yourself if you wanted to, and you could just graph these points, right? -4, -1, 4, 0, 1, 5, 14 on a graph, and then connect the dots, and then work with the graph just like we did up here. That's a lot more work, though. Another way to do it is to not worry about that at all. What you can do is you can just work directly from the table. Usually, in this case, when you're doing tables, the one that's going to give you some trouble is the y-intercept. Sometimes. Not always, but sometimes. All right, so here we go. So the y-intercept is where it touches the y-axis. But another way of thinking about what the y-intercept is it's where the x value equals 0. So that's right here. So this is my y-intercept right here. It's when the x value equals 0. So 0, 1. Now for part B, we want our slope, right? Now, if you wanted to graph this and find your slope, you could, but that kind of defeats the purpose of the fast method, right, where you go over and up. The point of that is that it's supposed to be fast, but it's only fast because you already have the graph. When you have a table, it might be better to go ahead and go with the table approach. So what you're going to do is you're going to pick any 2 points you want from your table. So let's go with the top point here, -1, 4. And the other point that I've already circled, the y-intercept, call that 0, 1. And as for those 2 points there, we're going to call the first set of points the 1s, so x1, y1, and we'll call the second set of points there the 2s, so it's x2, y2. And once again, if you use the formula method to find the slope before, you're going to find it's really no different at this point. So you have y2 minus y1 over x2 minus x1. And you got to be careful with those double negatives. The formula is minus, right? And x1 is negative, so you have minus and -1. So watch out for the double negatives. 1 minus 4 is -3, and double negatives become positive, so it's over 1. So my slope would be -3. Okay? Now, the function is going to be decreasing, and the reason it's decreasing is because the slope is negative, right? But another way you could tell is by looking at the table is that notice my x values as I go from the top to the bottom here, they're increasing from -1 to 0 to 5. That's kind of like you're going to the right on your graph if your x values are increasing. So what's happening as x is increasing? Well, as x is increasing, the y values are actually decreasing. It goes from 4 to 1 to -14. So you have a rise that's negative and a run that's positive, which is a decreasing function. Okay, so I want you guys to go ahead and pause the video here and try this problem right here. See if you guys can find the y-intercept, the slope, and then determine if it's increasing or decreasing. Okay, so for part A, my y-intercept is where x equals 0. So my y-intercept is at the point 0, 5. To find the slope, you're going to pick any 2 points. It doesn't matter which 2 you pick. I'll go with this point and this point. So we have 0, 5, and we have 2, 6. And we're going to call the first pair the x1s and y1, and the second pair the x2 and y2. And then we do our y2 minus y1 over x2 minus x1, and we end up with 1/2. as a result. So my slope is a half. And since that's a positive slope, that means that my function would be increasing. But another way that you can tell if the function is increasing or decreasing is to look at your y values. As x is increasing, we're going from 0 to 2 to 8, x is increasing. As x is going up, y is also going up. And so you have a rise that's positive and a run that's positive. So rise over run would give you a positive in this case, an increasing function. All right. If you guys want to, go ahead and try number 5. You'll see if you can, well, actually, I said if you want to. I would encourage everybody to pause the video and try this one. Something interesting kind of happens here. But if you think you already know what it is and you want to skip, that's fine. All right, so first of all, y-intercept is 0, 2. The slope, that's where one of the interesting things happen. So we take one point, like negative 1, 2, and we take another point, like 0, 2, and we're going to use our little x1, y1, x2, y2 formula. So 2 minus 2 over 0 minus a negative 1 gives me 0 over 1, which is 0. So we have a 0 slope. Anytime your slope is 0, that means the function is constant. So that's the difference right there. You could also tell that by just looking at your y values. They're constant. They never change. The y values are always the same. So the function is constant. All right. Number 6. Let's go ahead and move on to the last thing before we end our lesson for the day. We looked at how you can find slopes and y-intercepts with graphs, with tables. Now we're going to look at how you can find slopes and y-intercepts with equations. Okay. So one way is you could plug some numbers in for x and get some answers for y. And you could get a table of values and do everything we just did. Or you could graph it from the table of values and do what we did in the beginning. But it's actually way, way easier than that if it's in slope-intercept form. Sorry, let me back up a little bit. Slope-intercept form is when your equation has this format to it. Y equals mx plus b. Then we have a little bit of a shortcut. We know that my slope then would have to be 2. And we know that the y-intercept would be negative 4. So I'll go ahead and write these out. So my y-intercept would be negative 4. My slope would be 2. And how can we tell if it's increasing or decreasing? Look at your slope. It's positive, so we have an increasing function. So it's actually pretty easy when you have an equation in slope-intercept form. The number in front of the x is your slope. The other number is your y-intercept. Okay. So I'm going to let you guys try one of those, and that'll close out our lesson for the day. So here's one for you guys. Pause the video and try number 6. Okay. The y-intercept is 0, 6. Y-intercept, the x value is always 0. And when you have y equals mx plus b form, the b represents the y-intercept value. So it's 0, 6. Part b, the slope is the number in front of the x there. So my slope is negative half. And since my slope is negative, this function would be decreasing. Okay. Now, just so you guys know, if you ever have an equation that looks like this, like just y equals a number, well, that number would be your y-intercept, because there's no x here, so there's no number with an x in front of it. But what you could do is think of it like this: 0 times x, because 0 times x means it's not there, right? But if it's 0 times x, that means your slope is 0. So anytime you have a function that looks like y equals some number, what that's going to be is a constant function. It's going to be a flat line function, okay, with a slope of 0. Anyway, we'll stop there for today, and then you guys are going to go ahead and work on your homework. You're going to have these notes and the homework ready for turn in by our next class.